Bonjour, class. Welcome back to another week of science e-learning. We're going to start off today with talking about the difference between a chemical change and a physical change. This is a review from 6th grade. Please think back. If you remember the one type of change, you're going to get the same substance. The other type of change, you get something with totally new properties. For example, if you were to take a glass jar and you throw it on the ground on a sidewalk and it shatters, each of those little pieces is still made of that same glass that you had. If you take water and freeze it, or you take water and heat it up, the ice that you form or the steam that you form is still water. So these are physical changes. What you wind up with has the same properties and is the same stuff you started with. That's a physical change. If you have a substance and you mix it with something else and you get something with totally new properties, that is going to be a chemical change. For example, if we take sodium salt, which is poisonous to humans, and chlorine gas, which is also poisonous to humans, and we mix those together, we get something we sprinkle on our French fries, and that would be table salt. So two poisonous substances combined together give you something totally new with totally new properties. That's a chemical change. This week, we're going to focus on weathering, specifically of rocks. So by the end of the lesson, you need to be able to explain the difference between chemical and mechanical weathering, and also be able to explain the difference between weathering, erosion, and deposition. We'll focus on weathering this week, get into more of the types of erosion and deposition next week and the week after that. So we're going to take a look at these two mountain ranges. We've got the Sierra Nevadas and the Appalachian Mountains. Notice the characteristics of each. The Sierra Nevada mountains are actually younger than the Appalachian Mountains, and you can tell because they're real jagged peaks. They don't have the plants growing on them. They haven't had time to break down, form soil. It takes a long time for that to happen. So the Appalachian Mountains are actually going to be older. Weathering is just the process that breaks down the rock and other substances on the surface of the earth. The rocks get broken down into smaller pieces, and that can be done either with mechanical weathering, which would be through physical changes, or through chemical weathering, which is by chemical changes. One crazy long word we were supposed to learn this year is uniformitarianism. If you look at the word, you see the word uniform at the beginning. Uniform meaning it's the same. So uniformitarianism is basically just saying that the things that are shaping the earth now are the same things that shaped the earth in the past. Mechanical weathering. This is making the rock smaller by using physical changes. Those smaller pieces are going to have the same properties as the rock that you started with. So you're breaking the rock down using physical changes. A couple different ways we can do that. The first one's ice wedging. The water gets into the cracks, and then it freezes. As it freezes, it expands. It's going to break the rock apart. Living in Northeast Ohio, we see this a lot. It's what causes our potholes on our streets. If you go to Florida, you're not going to see that as much because they don't have that freezing and thawing constantly through the winter. Heating and cooling. Sometimes there are areas on the earth where the sun just beats down on the rock all the time. We also have forest fires. And when it heats the outside of the rock, the outer layers are going to expand. The center is going to be colder and still contracted, which I know that sounds weird when we just said that ice actually, when water freezes, it expands. It's one of the few things that does. Most things are going to expand when they heat up and contract when they are cold. So the rock heats up on the outside. It's going to get expanded, and then the inside is still tighter packed together. So those outer layers, as they're expanding, are going to actually start to flake off of the rock over time. Plants can grow into the cracks of the rocks, and as those roots get bigger and bigger and bigger, they're going to apply pressure to the crack, and it's going to make that crack split further and further apart. We do call this root pry, and if you look back at our weekly chuckle for this week, it applies to this idea of plant growth and specifically root pry. We have animals digging through the ground. As they're digging and making their burrows in the ground, they're going to be loosening the soil and breaking the rocks apart. And of course, we love Timon. There's my Lion King reference. If you've ever taken a walk on the beach on a windy day, you may have felt the sand blowing against you. This is abrasion. Sometimes the sand particles and other rock particles get picked up by the wind. They can also be carried by the water or ice, like in a glacier. And as they go across the surface of other rocks, it's going to almost act like sandpaper and break those rocks apart over time. We also have chemical weathering, where we're chemically breaking the rock down through chemical changes. The smaller pieces of rock are going to be different than the original rock. This process can create holes or even soft spots in the rock, and then mechanical weathering can take place. The first one we're going to talk about is using water. The water can dissolve the rock. Sometimes we have hydrolysis happening, which is just a chemical reaction where you've got a chemical compound in the rock and the water, and there's a chemical change that happens. Most of you have probably seen rust on a car. Well, rocks can also rust. It's called oxidation, where we've got oxygen combining with the iron in the rock and it produces rust. Just like on a car, it's real fragile and easily broken apart. It's weaker than the metal that used to be there. Same thing on a rock. So those rocks oxidize because they have iron in them. We also have carbon dioxide. The carbon dioxide gets dissolved in rainwater, which makes carbonic acid, and that sinks down through the soil and will actually break down marble and limestone underground. So here are some pictures. You can see some stalactites and some stalagmites in the one picture, but the water will drip down into these caverns and can break down the marble and limestone underground. So we said living organisms can, with the plants, create root pry, and they can dig in the ground and break up the rocks. Well, we also have living organisms acting as a type of chemical change as well. Some plants excrete a weak acid that can break down rocks. Lichen are an example of this. And what's kind of cool is that lichens are actually a fungi and an algae living together in a symbiotic relationship. The fungi release the chemicals that break down the rock into those minerals, and then the minerals are released and then they get consumed by the algae. So living organisms can act as a mechanical type of weathering and as a chemical type of weathering. So you want to keep that in mind when you do the check after the notes. Go ahead and stop this video and go to the notes and watch this quick video and then come right back. For number 5, we've got acid rain. You've probably seen the effects of this. We have sulfur, carbon, and nitrogen compounds that get released when we burn fossil fuels, and then that reacts with water vapor in the clouds, and then it falls back down to the earth as acid rain. That will damage different types of rocks. Here we've got some gravestones and statues. Some areas of the earth have bigger issues with acid rain. Some don't have as much. So how quickly the rock is going to weather is dependent on 2 things. First, the type of rock. What kind of minerals make up the rock? If they dissolve in water, they'll usually weather a lot faster or break down faster. If they do not dissolve in water, that means they will weather a lot slower. The climate is the second thing that affects how quickly these things will weather. Weathering is faster in wet climates and if it is a higher temperature. So the hotter it is, the wetter it is, the faster the rocks are going to weather in that area. Again, keep this in mind and refer back to it as you're doing your check after the notes. Erosion is when we start to move all of this rock that we weathered. So when you have a rock and you break it into pieces, that's weathering. Erosion is where we pick that stuff up and carry it somewhere else. Now, because we're breaking something down and we're moving it out of there, we consider this a destructive force. We're wearing away the surface of the earth in that area. Now, as we've said before, if you're destroying it in one place, you have to be building it up somewhere else because the overall size of the earth is not changing. So weathering breaks it down, erosion carries it someplace new. When it gets to that new place, it's going to deposit it or drop it. I always think of depositing money at the bank. You take your money there and you drop it off or you deposit it. So when sediment is laid down in these new locations, we call it deposition. Because you're dropping it and you're building up the surface of the earth, we call that a constructive force. So don't forget what the constructive, destructive forces are. Constructive is building up, destructive is wearing away. Please email me if you have any questions. Make sure you refer back to these notes when you're doing your check. And please feel free to email me with any questions. I hope everybody is doing well and staying safe. I really miss all of you. I can't wait to get back to school to finally get to see everybody again. Take care and au revoir.